let's just finish this. Let's else print below average, for example. Let's say that's our code. So we will enter numbers. If the number is greater than 85, then A grade. If when this condition becomes true, then this print will execute and we will out of the structure right there. If this condition is false, then this condition will be checked. If this condition becomes true, then this print will execute and we will be out of the structure. If this is false and this is false, then this will be checked. If this is true, then we print B grade and we are out. But if this is false, then this will be checked. And if this is true, then we will print B minus grade and we will be out. If this is also false, then we will dive into else part and we will say, okay, below average. So let's see, for example, let's say the marks are 82. So A minus grade, that makes sense, A minus grade, because the marks are smaller than 85 and larger or equal to 80, so A minus grade. Yeah, let's run this again, and we have, let's say, marks, let's say 64, below average. Okay, great. So you see this if, elif, else, this can go as long as you want, depending upon your logic. So great, and further, you can combine several comparisons, several booleans together with ands and ors and nots, whatever you like to do. Let me give you one more beautiful thing. Let's create an else without writing an else. Let's just write elif and implement else, completely else. So we are not going to write else explicitly, but we are going to write a program that actually simulates else. So let's see, if A equals, let's say, 3, if A is larger than 10, then print, let's say, larger than 10. Now we are not going to write else, but we are going to achieve the else part. If not A is greater than 10, you see, then print else part. You see that? I mean, that's beautiful. If this condition is true, then go there. If this condition is false, then not of false is true, then you land here. And you need not to write an else part if you want. Just I have implemented else part using elif. So you see that? So else part. So we are in else part. If A is, let's say, 13, then we will print, okay, greater than 10. Oh, just for fun. Okay. Okay, great. So we saw if condition, its shorthand, and else if structure in a bit more lengthy way. So in the next video, we will see if condition inside or in the body of another if condition, which is called a nested if. So hope to see you in the next video. In the last video, we saw if else if structure. In this particular video, we will see nested if, or simply called if inside the body of another if. So let's take an example to understand what nested if condition is. Simply we can understand if condition inside another if condition, that's all. Rest of the story is the same. The way if works, it works even if it is inside the body of another if, or anywhere actually. So let's say we have input a number and then we check if x is larger than 10, then you move inside the if condition, if that is true. If that is false, then you are here, whatever you write here, it will work from here. But let's say x is greater than 10, then you print your number is greater than 10, your number is above 10, let's say you print that. Now, after this statement, you move to this statement and you just make another check. if x is larger than 20. Now you see this if condition, this particular statement is inside this particular if condition. If this condition becomes true, only then you dive in. Otherwise you're not. So here you're checking if x is larger than 10, then you move inside, and inside you're making more checks. So for example, if x is larger than 10, then you print or do some stuff here, and then you apply further more checks, more granularity, more whatever your logic is. So let's say here you are checking if x is larger than 20. Now if this condition is true, then you move here, else. Now this else is of this if. If x is not larger than 20, then you move to this else part, and you're here. So, and we can have another if inside this particular if, or an if inside this else part, and so on. So if inside an if is called nested if, and we can have, deep structures, for example, if, then something, then if, then something, then if. So maybe we can have a very lengthy structure, if nested if structure, depending upon the logic. So let's get ourselves comfortable as always by writing the code on Jupyter Notebook, because that makes much more sense when we see things running on the notebook. So let's say a is let's say again int, let's say we take some number, and if a is larger than 10, then we say okay, print larger than 10, and do more stuff, print, let's say inside the top if condition. Okay, then maybe we have another check. If a is larger than 20, then say print greater than 20. Greater than 20, and you can print now, print inside the nested if. Okay, else print smaller or equal to 20, and then print, for example, inside the else part of nested if. That's it. And you can print here, print outside all ifs. Fine. So that's it. That's a structure. So let's see. Let's give an input which is larger than. By the way, if input is not larger than 10, this if condition is false, then you directly dive to this print statement, and all this structure is not going to be executed. This complete thing is called the body of this if condition. And the body will only execute if the condition becomes true, whether that condition is just a single condition or you have a combination of a lot of comparisons and a lot of booleans, whatever. If this condition becomes true, whatever that condition takes form of, then and only then you dive into this part. And when you are in this part, then that's a whole new universe. Then you are on its own in the new part. In the new part, for example, if this condition becomes true, then you are in this part. That's the body of this particular if condition, and that's the body of the else part. See, the body of the top if condition has this kind of alignment. All the statements that are in the body of if condition, they start in the same alignment, and all the conditions, all the statements that are in the body of this particular if condition, they have their own alignment. And this indentation is necessary just to define, for example, which statement is in what kind of block. For example, if I just press a tab, then another tab, then this print statement is in this else part. And this is the indentation that is defining the placement of this print. If, for example, I press I align this with this this particular structure here. Then this print statement is inside this if condition. This is the indentation that is defining the placement of different statements. And if the print starts from here, then it is completely outside of all if conditions. It is like this way. So let's run this code and see what happens. Let's say we print, let's say we just write a equals, let's say 12. So what do you think? What should be printed? If a is 12, then first of all, this condition is true. So greater than 10 will be printed inside the top if that will be printed. Then this check will be executed and this condition will become false because 12 is not larger than 20. Then you will go to the else part and less or equal to 20, this string will be printed, and then inside the else part of nested if that will be printed, and then you will be out of all if condition, then outside of all ifs that will be printed. So let's see whether whatever we have said is correct or not. So yes, greater than 10 inside the top if, less or equal to 20 inside the else part of the nested if, outside all ifs. Yeah, so that's what the nested if is. And by the way, you can have for example more if conditions inside the nested ifs. For example, you can have one more condition here. If a is larger than 30, for example, then do what? Then print it is larger than 30 as well, and further print, maybe not necessarily that you always write print statements. You can do any interesting stuff inside inside the nested if of nested if. Fine. And then you can write the else part of this particular if condition here if you want to, or whatever. I mean, you can have as hilarious structure as you want, but that completely depends upon the logic. Or you may have an if condition inside that else part here. For example, you can write an if condition here if whatever. That is also perfectly fine. So if a is larger than 20, then you print this. If a is larger than 30, then this, for example. And let me write the else part here. Else print less or equal to 30, and we can print inside the nested, inside the else part of nested if of nested if. Okay, so wow, you see that program? Let me just scale it down so that you can see that completely. See that program? I mean, yeah, it makes perfectly sense to me. For example, you take an input. If that is larger than 10, then you're here. If it is larger than 20, then you are here. If it is not larger than 20, then you're here. Okay, so let's say it is larger than 20. If it is larger than 20, then you're here. Further, if it is larger than 30, then you're here. Otherwise, you're here. And by the way, if a is not larger than 10, then you're directly here. Wow. So let's run this code. Let me just scale it down so that you can see it more. You can see more text, let's say. So let's run this. No errors. Great. So let's say the number is, let's say 25. So what do you expect the result? So the number is 25 is greater than 10 inside the top if. It is greater than 20 inside the nested if. It is smaller than or equal to 30. So inside the else part of nested if, and then outside all the if conditions. Great. Yeah. You enjoyed that? I enjoyed that. Great. Okay, so that's about the nested if. One more thing that I have already told you, but just let me tell you the power of indentation. You are here, for example, in this particular if condition. That's the if condition, and that's the nested if, and that's the else part of this if. If you move this else part in the indentation or the alignment with this if, then this is else part of this if, and this is not the else part of this if. So remember the power of indentation. This is the indentation that defines which part belongs to what kind of block or structure in Python. In other languages, sometimes, for example, in C++, they normally use to write these curly brackets to define a block, and their indentation doesn't really matter. But in Python, this is the indentation that actually defines each and everything. So for example, this is a crucial example. If this else just moves backwards and aligned with this if, you get this else with this if. These are two if and else structures. This is still nested if without an else part. And if this else move somewhere in between, I mean, if this is not aligned with this if, this is not aligned with this if, you get a syntax error because that is not a proper indentation. So focus on indentation. That is really, really important. Yeah. So although I've told you that the indentation has already told you, but I just found to make a slide over this else part because that's important. Sometimes you may get confused whether this else belongs to this if or that if. Well, the indentation defines this else belong to what. Okay, I end this control flow indentation here. So from next video, we are jumping toward loops. But before loops, I just want to write a lengthy program in if, else if, their combinations. I just want to write a Jupyter program for you to get comfortable with if, nested if, the conditions that are ands and ors and nots or stuff like so. So in the next video, we will be practicing more on Jupyter for if conditions, and then from the next video, we will be jumping toward loops, the very, very powerful structure. Okay, hope to see you in the next video. Okay, so let's just practice this if condition a little bit more. In this particular video, we are going to achieve a particular task. So let's design some task here. By the way, this is comment. Comment is, it starts from a hash symbol, and that's a statement that will never be executed. This just describes your code, for example. So it is not there, but it is there as a text, but not as a code file. Like hash sometimes represents comment or description with a single line. If your comment goes on multiple lines, it is good to write a multi-line comment. So that's a single line comment, for example, single line comment. The multi-line comments, they start with 3 quotes and then end with 3 quotes. So whatever you write inside in these in this particular block, that's a multi-line comment. So let's describe our problem in this multi-line comments, because that's the problem in form of text, and then we will be solving that problem using the code. So that's just description of the problem. Let's say user will enter a floating point number, let's say 238.915, let's say. Okay, your task is to, so let's just more readable. Your task is to find out the integer portion before the decimal, before the point, let's say, before the point. In this case it is 238, and then check whether if that integer portion is an even number or not. So just print yes or no. So print even if it is even number, otherwise print odd. So that's the problem statement. That's the problem that we are going to solve. And this is just comment. Now we are outside the comment. That's a multi-line comment. Yeah. So how to solve that problem? Yeah, how to solve that problem? So let's start solving this problem. I'm going to spend some time on this program just to get comfortable with the if conditions. Let's say that number is x is input. Let me convert that input, enter a real number, let's say. Okay, we are just assuming that the user will enter a real number. It's a real number. Real number might be, 238.0, that's a real number, or 238 itself, that's also a real number. That's okay. But we are not assuming that the user will enter, let's say, some characters like ABC or stuff like so. Just assuming that. Okay. Now, assume that x contains a real number. It may be an integer by default. Maybe user just enters 10, and that's it. So it may be already an integer. Then we have to check whether that 10 is even or not. Or the user may enter 11.7, or the user may enter minus 34.7, or the user may enter just 0, or user may enter just 0.35. There are a lot of possibilities that the user come up with. This x can contain any kind of number, and we have to check according to. So how can we move? Let us just see whether that number, let us just extract the decimal portion, the portion before point. Let us just extract that. How can we extract that? There are two conditions. First of all, let's see, if x is positive, then do what? Else do what? So let's write this structure first. If x is positive, then what we have to do, and if x is negative, then what we have to do. So if x is positive, then what we do, we just so what should we do? I'm just stuck here. How can we extract the decimal portion, the portion without this particular thing? How can we extract that? That's tricky. That's kind of tricky. Yeah. So any ideas? I guess this the structure I'm using. Let us just first think that x is positive. Just make our life easier, and then if x is positive, it's a positive number. How can we extract this portion out? Just the number that is below, that is before the decimal point. What should we do? Can we apply a round function? Will that help? X, will that help? Helps? Yes or no? Round function. So let's say y contains the rounded value of x. Then, so what? Then how can we extract the decimal portion, the integer portion? Or maybe there is a function that actually round downs. Let me check whether there is a function float or not. No, float is not a function, I guess. So let's say round x. Okay, now y contains the rounded value of whatever the x is. We are now assuming that x is positive. Okay, then what? Now if y is larger than x, that means we moved up. Okay, we moved up, the round goes up. In that case, what we do is we just subtract so we just subtract the integer portion. So the let me integer portion. Let's say that's our variable name. Then the integer portion is simply y minus 1. Is that correct? Is that correct? If y is larger than x, then integer portion is simply y minus 1. For example, just think about it. If when for example, if the value was 29.6 and the rounded value will become 30, so 30 minus 1 will be 29. That is what we are interested in. So yeah. So otherwise, if, for example, else if y is not larger than x, then y itself is an integer portion. Y itself is an integer portion. Is that correct? I mean, is that making sense to you? That if, for example, if x is larger than, if the rounded value of x is larger than x itself, then we just subtract 1 and we get the portion. Otherwise, the rounded value itself is the portion. Let's just run this code for now and check whether whatever we have done so far is correct or not. So after that, just print, let's say, the integer portion. Let's just print that. Okay, so enter a number. Let's say the number is let's say 25.367. let's say. Obviously the integer portion here is 25. So let's see our program returns 25 or not. Oh, the result is 25 magically. Oh my god, we found 25. Let's run it again. Just to see. Okay, let's run this again, and this time let's give it to 45.8. Okay, the integer portion is 45, but when we will round, we will get 46, and 46 minus 1, we will dive into this particular if condition. Let's see. Oh, the result is 45. We are still moving very well. Great. That's great. So okay, let's play with it. Let's give 0.2. The result should be 0. It is 0, right? Let's run it again and give it, let's say 4. That's it. The result should be 4 now. It is 4. Great. So we are working very well. We have extracted the integer portion as long as the number was positive. Okay, great. What if the number will be negative? Let's say that was true. If that was true, so that whole logic works if x was positive. So if x is positive, then whole this logic just works. Okay, then else, what should we do? If x is positive, then this logic works. If x is not positive, then what will happen? Then how can we find out the integer portion? Because first we have to find out the integer portion, and then we have to find out whether that integer portion is even or not. Finding out whether that integer portion is even or not might be simpler, but first we have to find out the integer portion. So for example, let's check the behavior of round function on negative numbers. Let's say round minus 9.3. So the result is minus 9. Okay, if we say okay, round minus 9.6, the result will be minus 10. So it looks like the same as working in the positive numbers. So round function is actually working roughly the same way it should work in the positive numbers. Okay, so what should we do here? Any idea? Maybe we first convert by the way, yeah, maybe we first convert the number, let's say y equals round x again like before, but then what? Then what? So maybe this rounding helps the same way. Maybe the rounding helps the same way. We should extract this x out from this here, because it is going to work in the else part as well. Why to compute it? Why to write this redundant code? So y is round x, let's say. Then if y is greater than x, what should we do? If it is negative, y is greater than, then what will be the portion? It will be, the integer portion will be what? Y minus 1 or what? Y plus 1. Yes, you got the answer. That's y plus 1. Great. And else, I guess we have integer portion equals y itself, I guess. Yes, I guess that's the code. That's the code, I guess. Let's check, by the way, but I guess that's the code. By the way, this else part is same in both of these conditions. So maybe we can combine this code and write a more elegant code, but I guess this will work. Let us just print the integer portion just to check whether we are working well so far or not. So let's enter, let's say 12.3. The result is 12. Great. So it did not change our previous, I guess, our previous logic. So let's say there is minus 9.8. Now the integer portion should be minus 9. Oh, it is returning 10. Why is that? Why is that? Oh my God, this should be changed. When it is round, it may go that way. Or when it rounds, it actually becomes lesser than 10. Because when it rounds, it goes up and it becomes lesser than. In negative world, this condition should flip. Yeah, so we are making an error here. Let's fix that. Okay, let's run this again and see. Let's say minus 93.2. Minus 93, great. So then we have, let's say, let's run it again. Minus 8.9. Minus 8. I guess we are working perfectly fine. Once we have integer portion with us, we just write here at the very end, if integer portion remainder with 2, if that equals to 0, print even, otherwise else print odd. That's it. That's the whole program. Let's see, and let's see how is it running. Let's say 22.6, it's even. Let's say minus 87.3, that's odd. Great. So you see the power of if condition and how can we think in writing these programs and stuff like so. That was a lengthier video, I know, but I guess you get a very good look and feel of if conditions and thinking and building a logic and all that stuff. So in the next video, we will start loops. So that's a beautiful structure. Hope to see you in the next video. The best way to understand loops is to think about in a repetitive structure or repeating structure. Let me give you an example, and we will dive into this code in a while. The example is, let's say user gives you a number, let's say integer number, and you want to print all the numbers till that number. Let's say you start from 1 and you keep on moving and printing all the numbers as long as you reach that number. So for example, if user enters, let's say 5, your goal is to print 1, then print 2, then print 3, then print 4, and then stops. Then stop, just stop. Or let's say if user print, if user enter, let's say 3, then you print 1, you print 2, and then you stop. This is easy. If user enters in n, we can just print, we could have written this thing, print I. Let's initialize a variable I with 1, print I, and then I equals to I plus 1, or in Python we can write this quickly as I plus equals to 1. That means in I store I plus 1. This is the short form of writing this. And then after that you just apply an if condition. For example, here you can apply an if condition and say, okay, if I is smaller than n, you keep on printing, and after printing you just increment again this, then check the if condition and keep on moving. Well, that is feasible if n is 5 or n is 3. What if n is, let's say, 50,000? I mean, you're writing all that structure again and again and again. I mean, that's a whole lot of code. Well, the loops are just a solution of this kind of structure. When you want to perform same kind of task again and again, the loop gives you the facility to do that. For example, let's just consider a while loop. This is again a condition similar like a condition in if condition. Like in if condition, you evaluate this Boolean expression. That's an expression that results a Boolean value. While this condition is true, you will stay in this block. And after executing whole block once, you check this condition again. If this condition is again true, you will dive into this block again, then check the condition, dive into the block, then check the condition, dive into the block. As long as this condition stays true, you stay in the block, you move inside the block. Once this condition is false, then you exit this while loop, then the loop terminates and you move on to the further processing. Just like in if condition, just like if conditions, if the condition becomes false, you exit that if condition and you go moved on. So in this particular case, for example, if n is 5, let's say if n is 5, user give an integer number that is 5. I is equal to 1. Now 1 is smaller than 5. The condition is true. You move inside. You print I. The value of I is 1. So that's what you print. You print 1. Then you change I. You increment I with 1. That means I equals I plus 1. So I becomes 2. Now the body of the loop finishes. That's whole body of the loop. The body of the loop can have many statements, a whole block of code. Once I becomes 2, you move on and you check, okay, 2 is smaller than 5. Yes, it is true. You move inside the block again. You print 2. Then you update I. The loop body finishes. Once the loop body finishes, you go and check the condition again, whether that condition is still true or not. It is still true. I is 3. 3 is smaller than 5. Yes, you move inside. You print 3. You update I. You check the condition. 4 is smaller than 5. Yes, you move inside. You print 4. And then you update I. And then you move on. Now 5 is smaller than 5. False. Once the condition is false, you will not dive into the body of the loop. You will exit the loop and you will print done. And that's it. Done. So this loop becomes very handy in applications that have repetitive structures, and in most of the interesting programs, most of the interesting problems, these are the loops that play a very huge role. So let's go to Jupyter just to get our hands on this loop. For example, let's say x is again, let's say int or n. Let's take n. N is int input. Let me make this a little bigger, just to, let's say that input, and input is a number. Let's say n. I is your certain let's say 1, while I is smaller than n. You may have written this parenthesis just to create the readability, just to make the readability, and otherwise, I mean, this is also okay. That's perfectly fine. if as long as I is smaller than n, keep doing the following. What you do is print, for example, the square of I. Print the square of I. That's a square of I, let's say. And then you say print, for example, this is iteration number, and then you just print I. That's the iteration number I of the loop. That's the iteration number I. This is just a string. This is just a string, and that's a variable. Its value will be printed. This print function takes as many arguments as you pass. So you can write a comma here and continue whatever you want to print. That's a very flexible function. Okay, then what you do, you say, okay, I plus equals to 1. By the way, this I plus equals to 1 is the same as I equals I plus 1. You see, I have just commented here just to explain what this is doing. If I just write I equals I plus 1, that is also correct in Python, but that's kind of a shorthand. Okay, and that's it. Now again, when I de-indent, I'm outside the loop. This is print loop done, for example. So that's the code, for example. So let's run this code. Let's run this code. For example, let's say n is equal to 5. Then we have 5. So this is 1. This is the iteration number 1. Then 2 square is 4. This is the iteration number 2. Then 3 square is 9. The iteration number 3. Then 4 square is 16. This is the iteration number 4. And then the loop finishes. That's it. That's a first snapshot of the loop. We will continue from here onwards in the next video, and I will show you more and more flavors of this loop. So hold on and wait for the next video. Okay, in the previous video we saw while loop, and we saw one program related to while loop, just printing a bunch of numbers till a particular number. Well, when you are inside the body of the loop, that's a whole new, you can write whatever you want to write. For example, you can apply an if condition inside the body and check that at each iteration a particular decision should be made or not. For example, in this particular case, I'm going to print I whenever I is an even number. So I is some number. If it is even, then print it, else pass. This pass statement, for example, is just a statement of saying that do nothing. It is just a shortcut of writing do nothing. We could have omitted the whole else part along with this pass, and still the code is equivalent. But sometimes writing this pass make the code readable. Just so writing this pass statement just means do nothing and just move on. If we omit else statement and we omit this parse, that's perfectly okay. So for example, let's try run this code. Let's say n is 5. I equals 1. 1 is less than 5. Yes. 1 is not an even number. So go to else part. Else means pass, which means go on. And then increment I. This print statement is outside the loop. This is aligned with this while. This is not inside the body of the loop. Otherwise, it should have been indented inside. Now I is incremented. I becomes 2. Now move back. 2 is smaller than 5. Yes. 2 remainder 2 is 0. Yes. So print 2. So 2 will be printed. Because if executed, else will not execute, and I will increment. Because I is not inside the if condition. It is inside the body of the loop. So I incremented, I becomes 3, you go back. 3 is smaller than 5, yes. 3 remainder with 2 is 0, false, so pass. I plus 1, so I becomes 4. 4 is smaller than 5, yes. 4 remainder 2 is 0, yes, so print 4. So else will not execute. Now increment I. Once you increment I, you get, for example, I equals 5. Now 5 is smaller than 5, false. So you go out of the loop and you print done, and that's what this code is. So you can have if condition inside the loop, you can have nested if inside the loop, you can have loop inside the loop, nested loops. We will see examples of nested loops as well. I mean, that's all allowed, or sometimes really required. Okay, so next there are two important statements that are there. One is break, one is continue. I want to focus these statements because they have a deep link with loops. A break statement, wherever written inside the body of the loop, tells that exit the loop immediately. Whenever this break is encountered, whenever this break executes, it exits the loop immediately and brings you outside the body of the loop. That's what it does. Break. So for example, if I becomes divisible by 17 and the remainder becomes 0, you will print a break. And then when this break statement will execute, you will exit the loop immediately, regardless of what is the value of I, what are other states, whatever. Break exits the loop. Okay, great. Now the continue. Continue statements, continue statement wherever encountered, continue brings the next iteration loaded regardless of the remaining statements in the loop. For example, when this continue will be executed, no matter how many statements are there onwards that are there in the body of the loop will not finish its iteration by going through all the remaining statements, but it will start another iteration immediately. So continue basically skips the remaining body of the loop and starts another iteration. Here I have written this true. True means while true means always run. You might be thinking always run. It's an infinite loop. Will it when we will exit the loop, because this true statement will always stay true. We're not changing this true anymore. There is no condition here. That's true. While true means always go inside the loop. But whenever this break is encountered, you are outside the loop right away. And this break exits the loop. This continue skips the remaining portion of the loop body and starts the new iteration, starts another iteration. So this continue means start another iteration immediately, skip the rest of the statements. So rest of the statements inside the loop body. Okay, so let's just practice this break and continue just in Jupyter Notebook to get a better look and feel of the loop. So let's say we have, let's say n equals, let's say 10, or we might have taken that as an input. Let's say n is equal to 10 while true, which means keep moving. We might have taken some value here, I equals, let's say 1, while true, if I remainder with, let's say 9, if that is equal to 0, then just break the loop. Else what you do is really you increment. Else what you do is if I is not divisible by 9, then what you do is I equals I plus 1. That's true. By the way, previously we have written this way, so either way is fine, whether you write a short form or this form. So else this. Okay, and that's it. The loop finishes. That's the loop. After the loop, you just write okay, print the loop is done. So let's see what's the output. The output is done straight away, and the reason is why it is, oh, 1 is divisible by 9, only then you could have break. While true, why the loop? Oh, it does not print anything. We could have printed some statements so that we know that we went inside the loop or not. okay, so inside if, so for example, print inside else. So let's run this again. Oh, okay, great. Inside else, inside else, inside else, inside else. The first time it go inside if, that time it breaks and it goes out and prints done. That's what this break statement does. So let's see an application of continue statement. Let's, for example, just copy and paste that code into another cell and see how this continue works. So let's say we have a loop like so. So what we say is like this: if I is 9 is not equal to 0, if this is the case, if I is not divisible by 9, what you do is you take I plus equals to 1 and then continue to the next statement. And whatever else you write here, for example, print something, print something else, whatever, that will not be printed. And once the continue will be encountered. Whenever this I is whenever this I divisible by 9 is not true, if I is, then you continue. Once this I is divisible by 9, for example, then you will not dive into this if condition. Only then these two statements will be printed, because this continue will not allow anything further that should happen. And once these are printed, let's say we break our loop right there, let's say. So if, for example, for the very first time 1 is not divisible by 9, so I equals 2, so continue, these three statements will not be executed, the next loop, the next loop, the next loop. Once this if condition becomes false, this continue will not operate, and then we print this statement, then only then we will print this statement, and only then we will break and we'll exit the loop and print the done. So let's print here, print inside if. So let's run this code. Let's run this code and see what happens. That's the code. Maybe I should just, yeah, that's a better font. Let's run this code. So when the code is run inside if, inside if, inside if, you see when you are inside if, when you continue, when this is the body of the if condition, when if condition completes, it should print these two things. But continue is telling the cursor to go back to the next iteration and move on. And once this if condition becomes false, only then you get this thing printed, this thing printed. If this break was not there, you then again was going to the while loop, and you will be running an infinite loop, and then you have done. So that's what this continue and break does. So in the very next video, we will see another kind of loop. Here we saw the while loop. In the next video, we will see a for loop. Very powerful and very famous kind of loop. For it does almost the same stuff as while loop. While the while loop runs based on a condition, the for loop, it runs based on counter. It's a counter loop that many times it should run, and so on. So we will see the details of for loop and the applications of for loop in the next video. Hope to see you in the next video. Okay, in this video we are going to discuss for loop, another kind of loop. In the previous video we saw while loop. Although most of the stuff, almost all of the stuff, can be achievable through while loop, but sometimes it becomes handy to apply for loop. In this particular example, I'm going to populate a list. So before actually moving towards for loop, let's see very shortly what a list is. Although we are going to explore this list in much more detail when we will discuss the data structures module, but just for the sake of example, a list is a collection of different kind of elements. For example, 2, 3, 4, that's a list of 3 elements. So 2, 3, and 4. The list can contain different type values, for example, 2, 3.4, and stuff like so. We can access different elements. For example, L of 0 means the very first element. The indexing, this is called the index. The index starts from 0, then index 1 is. So if we print, for example, print L of 0, the result that will be printed will be 2. Similarly, we can append more values inside a list. Append, let's say, 53, and the list, after this append operation, the list will be having these values 2, 3, 4, 53. We can remove, delete, update, and do a lot of stuff. We will see lists in detail, but just for this example, just think that list is a collection of a lot of elements, and we can add, insert more elements, we can delete elements, we can change elements, and so on. Or we can just initialize the list with just an empty list and start inserting elements one by one and expanding that list. Okay, now this is an empty list, for example, and for I is just a variable. For I, in this range is an iterator. Range 10 means sequentially give a number one by one starting from 0. Start from 0, give numbers one by one. For example, first time give 0, I will contain 0. Second time give 1, third time give 2, and so on. After every iteration, the range will give another number as long as the numbers, they are smaller than 10. So the last number that this range will return will be 9. So whatever this is written inside is not included, and it starts from 0. So as long as I is in this range, I is lower than 10. As long as